Well, welcome. I am Mr. Murphy, and in this video we're going to be looking at Power Standard skill number 28. In this Power Standard we're going to be looking at how to solve a right triangle. And what that means to solve a right triangle is that we are going to be looking for finding the other pieces of the puzzle, so to speak. If we're given a side and an angle for a right triangle, being able to find the measures of the other sides and angles basically. Well, we're going to break this up into a couple videos because there's actually a couple different scenarios we could look at. We could have a situation where we are given an angle and a side, and we have to find the other pieces of the triangle. Or there might be a scenario where we're given two sides of a triangle, and we have to figure out the measures of the two angles and the third side. So that's why this standard, we'll be breaking those up into two different videos. But first, let's look at some examples of some things that you're going to be solving on your own. So this is an example of a right triangle that we're looking at here that you would be solving on your own. So if you notice that they give us one of the angles is 30 degrees, they give us one of the sides is 5.2, and we're going to have to find the measures of the other angle, angle A, and the other two sides. But how do we do that? Well, there's some things that we need to know about. First off, what we're dealing with here is we're dealing with what's called right triangle trigonometry. And when we're dealing with right triangles, we have these three different what we call trigonometric ratios. It's a fun word to say, trigonometric. But we have these different ratios dealing with, and again, these are all dealing with right triangles. And maybe you're familiar with hearing about sine, cosine, and tangent. But the sine of an angle is a ratio. It's the ratio of the opposite leg over the hypotenuse. And we'll be looking at those parts of a triangle here in a minute. But the cosine of an angle, that's equal to the ratio of the adjacent leg over the hypotenuse. And lastly, the tangent of an angle is the ratio of the opposite leg over the adjacent leg. And there's an easy little phrase that will help you remember these different ratios, and it's called so, ka, toa, down here at the bottom. And so, when you remember that phrase, so, ka, toa, that so is the opposite over the hypotenuse, or the sine is the opposite over the hypotenuse. The cosine would be ka, which would be, the cosine is the adjacent over the hypotenuse. And toa would be referring to the tangent, which would be the opposite over the adjacent. So that's a phrase that will help you remember all of these different ratios. So let's talk about the parts of a right triangle. So all those ratios are referring to the different parts of a triangle. Now, the hypotenuse, as you can see from both of these right triangles, the hypotenuse is always the longest side of a triangle. Therefore, it's always going to be the side across from the right angle. And we identify the right angle with that little box. Now, you see that little circle with the squiggly line through it. That's referring to the angle measure. So if we're looking for that particular angle, or if we're given that particular angle, the other two sides of a triangle are referred to as the legs of a triangle. Now, one of those legs are going to be opposite of that angle, so we call that the opposite leg. And there's going to be another side that's going to be right next to it. It's going to be along with the hypotenuse. It's going to be the side that makes up that angle. So we call that leg the adjacent leg. Adjacent means next to, so that's the side that's next to the angle. That's not the hypotenuse. Now, the opposite leg and the adjacent leg are going to change depending on what angle we're looking at. That's what the second triangle down here is showing us, is that if the hypotenuse, you can see, is still the same, it's still across from the right angle. However, now the opposite leg is the side opposite that angle, and the adjacent leg now is going to be that shorter leg, the one that's to the right of the hypotenuse there and to the right of the angle. So that's just an important illustration to see how, depending on what angle we're looking at, the opposite leg and the adjacent leg are going to change, but the hypotenuse will always stay the same. Now let's look at how we're going to use SOHCAHTOA and how to solve a triangle. We're going to do this one together. So why don't we take a minute now to look at how to do this one, and then you're going to do one on your own. Okay, so let's see what we're given here. Here's how I always like to start these problems. I like to look at my angle. So the angle here is the 18-degree angle. And I like to look at what am I given. I'm given the side across from that, so I'm given my opposite leg. And what am I looking for? Now we're going to be solving these triangles. So I'm going to be looking for angle A. I'm going to be looking for side A. Now here's how we label sides and angles. If you notice, angles are always labeled using capital letters. Sides are always labeled using lowercase letters, and it's good to use the same letter as the angle across from it. So angle C is going to be across from side C. Side A or angle A are going to be across from each other. So I'm going to be looking for side A here, and I'm going to be looking for side C as well. So we have to find these other three parts in order for us to solve the triangle. Now, in order for us to figure out angle A, we need to remember that there's a total of 180 degrees in a triangle. Well, in a right triangle, we're always going to know 90 degrees of that triangle. So that means the other two angles are going to make up the other 90 degrees for the total measurements of the angles in the triangle. So in other words, to find angle A, we're just going to take 90 minus 18 to figure out what that missing angle is. And 90 minus 18 is 72, so that tells me that angle A is 72 degrees. Now, we need to figure out what side A is, and this is where we're going to use SOHCAHTOA. We're going to use those ratios, those trigonometric ratios that we talked about earlier. So how do we do that? Well, if you look at angle 18 and side 4, those are opposite of each other, so that's my opposite leg. So that means side A here is my adjacent leg. So if I wanted to find that missing measurement, I need to have at least an angle and a side, so I need to only have one variable that I'm going to be working with. So I'm going to be using the fact that I have the opposite that I know and the adjacent that I'm trying to find. That means I'm going to use TOA, so I'm going to use tangent. So I'm going to use the tangent of angle B, so 18 degrees, is equal to the opposite leg, which is 4, divided by the adjacent leg, which is side A. Now, to simplify this, there's a quick way and a long way. I'm going to show you the long way first. If I want to figure out, I want to get A by itself, so right now the only way I can do that is multiply both sides by A. Doing so will cancel out these two. Well, then what I'm going to need to do is I'm going to need to, so here's what I'd be left with. Well, then what I'd need to do is I would need to divide both sides by the tangent of 18 to get the A by itself. So if I divide both sides by tangent of 18 degrees, these would cancel out, leaving me with A equals 4 divided by the tangent of 18. Well, let's go back to what we had originally, so I can show you the fast way to do this. So originally we had the tangent of 18 degrees equals 4 divided by A. So a fast way to do this, if you remember, my answer was A equals 4 divided by tangent of 18 degrees. So all I would have to do, a fast way to do this, is just swap these two. So to find out what side A is, I'm going to take 4 divided by the tangent of 18 degrees. But the reason why we can do that, remember, is because I'd multiply both sides by A and then divide by tangent of 18. Now, before you go and do this on your calculator, you want to make sure that your calculator is in degree mode. It's really easy if you have a scientific calculator. You just look on your screen and you should see D, E, G somewhere on your screen. If it's in radian mode, you'd see R, A, D. You don't want that. You want to make sure that your calculator is in degree mode. If you have the TI Inspire calculator, if you drag your cursor to the sprocket up here, now Mike won't do that since I'm using an emulator here, but if you were to drag your cursor up to that sprocket, you'd see a little text box that'll pop up that'll tell you whether it's in degree mode or whether it's in radian mode. So again, you want to make sure that it's in degree mode. So if I take 4 divided by tangent of 18 in my calculator, we're going to get a decimal, and we're going to round that to the nearest tenth, and we're going to get 12.3 as our answer. So that means side A would be 12.3 units. So now let's talk about how to find side C. Now there's a couple ways we could do this. Since we're working with the right triangle, I could use the Pythagorean theorem, or I could use another trigonometric ratio, which is what I'm going to do here. So to figure out side C, what I do again is I look at this 18 degrees, and I know that side 4 is opposite that angle, and side C then is my hypotenuse. So if I'm trying to find C, and if I'm given that the fact that I'd have the opposite leg and the hypotenuse, that would be so is what I would use, which would be the sine of the angle. So the sine of 18 equals the opposite, which is 4, divided by the hypotenuse, which is side C, which is what I'm trying to find. And just like we just mentioned, I can swap these two to find out what C is. I would say that C is equal to 4 divided by the sine of 18. And if I do that on my calculator, again, we're going to get a decimal. And we round it to the nearest tenth, so it would be 12.9 is your answer. So that's how we get our other leg, the hypotenuse, I should say, is 12.9. Now here's a little note. It's important to remember that the hypotenuse should be the longest leg. So when you're checking your answers, if your hypotenuse ends up being smaller than either of the other two sides, you did something wrong, because the hypotenuse should always be the longest side. Okay, so why don't you guys take a minute now and see if you can't solve this triangle. So pause the video and hit play when you're ready to check your answer. Okay, so let's see what you did. This time, again, we're trying to find angle A. Side A would be across from it. Side C would be the hypotenuse. So we're going to be looking for side A, and then we'll be looking for side C. Again, angle A is going to be relatively easy because, again, there's these two angles are going to make up a total of 90 degrees. So if I take 90 minus 30, I get 60 degrees would be my measure for angle A. To find out the measurement of side A, I'm going to use the fact that the 30 degrees and the 5.2 would be opposite that angle. And that means side A would be adjacent to the 30 degree angle. So I'm going to use the tangent of 30, which is going to equal the opposite, which is 5.2, over my adjacent leg, which is side A. So to figure out what A is, we swap those two, so it's going to be 5.2 divided by the tangent of 30, which, if you round that to the nearest tenth, you get, actually, 9 is your answer. So that's how we get that answer of 9. And to figure out how to get C, what we're going to do is we're going to take, just like before, C is our hypotenuse. And it relates, and so again, we can use the opposite and the hypotenuse, so it's going to be the sine of that 30 degree angle equals the opposite, which is 5.2, divided by your hypotenuse, which is side C. Again, we can just swap those. We get C equals 5.2 divided by the sine of 30, and you get your answer, which is approximately 10.4. And so we have solved our right triangle there. Well, there you have it. That is how we solve a right triangle when we're given a side and an angle. So hopefully you feel like you've mastered this part of skill number 28 and can work on some of these problems on your own. Otherwise, make sure to watch the next video so you can see how to solve a right triangle if we're given two sides of the triangle. So with that, good luck.